Lesson 4.7, multiplying decimals. In the previous lesson, we began to work with multiplication problems where one of the two factors was a decimal. This lesson will crank it up a notch. Both of the factors will be decimals. So when we talk about this business of clearing the decimal point out, counting the number of place values we have to push the decimal point to clear it out, we need to count our total pushes. Let's see this in action. We'll focus on the odd numbered problems here. Number 1, 5/10 multiplied by 4/10. This can be done with mental math. First, let's count our pushes. Whoop, whoop. How many pushes total? 2. The new problem becomes 5 times 4, noting that we need to come in 2 places from the end to insert the decimal point. So 5 times 4 gets us 20, but then we come in 2 places from the end. Pew, pew, and insert the decimal point. We get an answer of 20 hundredths. Number 3, 4 hundredths times 5/10. Let's count our pushes. Whoop, whoop, whoop. 3 pushes all together. The new problem is 4 times 5, which again is 20. But this time we're coming in 3 places from the end. Pew, pew, pew. And of course, in this place, we will insert a 0. And that looks kind of goofy, but this is 20 thousandths. 5 hundredths times 8/10. Let's count our pushes. Whoop, whoop, whoop. The new problem is 5 times 8. We know we need to come in 3 place values from the end. 5 times 8 is 40. Pew, pew, pew. Notice that in that blank spot, we have to insert a 0. 40 thousandths. Number 7, clear out the decimal point. Count our pushes. Whoop. 1 push allows us to solve this problem as if it's 18 times 7. 7 times 8 is 56. 6 comes down, 5 gets carried. 7 times 1 is 7, plus the 5 is 12. Now, we're going to come in 1 place from the end to insert the decimal point. 12 6/10. Number 9, 18 hundredths times 3/10. Let's count our pushes. Whoop, whoop, whoop. 3 pushes all together. Solve this as if it was 18 multiplied by 3. 3 times 8 is 24. 4 comes down, 2 gets carried. 3 times 1 is 3, plus the 2 is 5. And now come in 3 place values. Pew, pew, pew. And insert the 0 in that blank spot. 54 thousandths. Number 11, 3 4/10 multiplied by 9/10. Let's count our pushes. Whoop, whoop. 2 pushes. Solve it as if it's 34 times 9. 9 times 4 is 36. 6 comes down, 3 gets carried. 9 times 3 is 27, plus the 3 is 30. Come in 2 place values. Pew, pew. 3 6/100. 13. Count our pushes. Whoop, whoop, whoop. 3 pushes all together. Let's solve this problem as if it's 8 times 13, but I'm going to flip-flop it to put the larger number on top. 13 times 8. 8 times 3 is 24. 4 comes down, 2 gets carried. 8 times 1 is 8, plus the 2 is 10. Now come in 3 places. Pew, pew, pew. 104 thousandths. 15, the directions say solve using mental math. 81 multiplied by 100th. Whoop, whoop. 2 pushes allows us to solve this as if we're dealing with 81 times 1, which is 81. But then we know we've got to come back in 2 place values. Pew, pew. 17, 9,037 times 100th. Whoop, whoop. 2 pushes. 9,037 times 1 is 9,037. Now come in 2 place values from the end. Pew, pew. 90 and 37 hundredths. The word problem here, 19. Stacy has 10 and 8/10 meters of decorative tape. She is cutting it into 100 equal pieces. And that is the same as multiplying 10 and 8/10 by 100th. So how long will each piece of decorative tape be? Okay. So I don't want to overcomplicate this, but I want to break down how this information is being presented to you. Think about the relationship between division and multiplication. In a sense, they're opposites, aren't they? So if we're taking 10 and 8/10 meters and dividing it into 100 equal pieces, well, that is the same as taking 10 and 8/10 and multiplying it by 100th. Or show that fraction as a decimal. 10 and 8/10 times 100. This is exactly what we've been practicing. Let's count our pushes. Whoop, whoop, whoop. 3 pushes altogether. Solve this as if it's 108 times 1, which is 108. Come in from the end 3 places. Pew, pew, pew. And we get our answer. Each of these tiny pieces is going to be 108 thousandths of a meter.